All right, so hopefully you've already taken a look previously at the factoring by GCF. So in that video, I talk about that we are looking at factoring polynomials. And factoring polynomials is the opposite of multiplying polynomials. And so the first strategy we looked at in the previous video was removing a greatest common factor. That goes to the front, and then you write what's left after you've done that. And that's a really important piece for today. So if you're unsure, maybe go do a little bit more practice or rewatch that video before you get into this one. So today, this video is looking at factoring trinomials by decomposition. Now, remember, a trinomial in its general form looks like this: ax squared plus bx plus c. That is actually called a quadratic function, and being able to factor quadratics and understand what a quadratic is extremely important in Math 20-1 and 20-2. Very foundational skill, kind of continuing forward. And so we're going to look at factoring trinomials today. So not all trinomial expressions can be factored. But when a trinomial can be factored, or it's what we call factorable, it can always be factored by a process known as decomposition. And the method is called decomposition because the coefficient of the linear term, and so the linear term, I guess I should say, is this right here. It's really just the middle term, and it's linear because the degree is 1. So because the coefficient of the middle term can be broken down or split into two numbers. So I decompose, or I split the middle term, and then I have this factoring process I can go from there. And so I broke the factoring process down here in a few steps. And so either I suggest you write these out on your own, or you photocopy, or I guess print out the copied version of the notes for this, because it's good to have something to refer back to as you are trying to factor on your own when you do some homework or quizzes or whatever. Okay, so let's take a look. So here is this trinomial, 2x squared plus 7x plus 3. And we're being asked to factor it. So the one thing I guess to know is anytime we factor a trinomial, so like if I have a trinomial ax squared plus bx plus c, trinomials can always be factored into a set of binomials. So really what they're asking us is what binomials got multiplied together to result in this trinomial. And here are the steps that we can go to find that out. So the first one is arrange that trinomial, if it's not already, from the highest degree to the lowest. And so we have an x squared, x, and then a constant. That's good. That's from the highest degree to the lowest. And the reason we want that is because I need to be able to say this is A, this is B, and this is C. Those designations are important. A goes on the highest degree, B is the linear coefficient or the middle term, and C is your constant. And we'll show why that's important here in a second. The other part of this first step here is I need to remove a greatest common factor if there is one. Now, that's not a requirement. That is an optional step just to make your life a little bit easier. So in this question, 2x squared plus 7x plus 3, there is no greatest common factor. So I'm just going to continue on to the next step. The next one says find two numbers. So now what I need to do is I'm going to find two numbers. So two numbers that multiply to A times C and add to B. Now, this is a skill some people are really good at and others are not so much. So let's go take a look. In this question, we said, so we're looking for two numbers that multiply to A times C and add to B. And I always set this little chart up for myself because it kind of helps people keep track. So A times C and add to B. Well, A times C in this example is 2 and 3. So we are looking for numbers that multiply to 6 and add to B, so add to 7. So two numbers that multiply to 6 and add to 7. Now, if you can't think of those two numbers off the top of your head, the best way to start is by listing all of the factors of 6. Well, what are the factors of positive 6? Well, 1 times 6 and 2 times 3. I could also go -1 times -6 and -2 times -3, but there's no other negative sign in this question, so I'm not going to include them. So 2 plus 3 is 5. Well, does that satisfy my conditions? Do these two numbers multiply to 6 and add to 7? No. So this line is not the one I'm going to use. 1 plus 6, however, does add to 7. So these two numbers are the numbers that I'm looking for. So what I'm going to do then is I'm going to split the middle term into the two numbers from step 2. So from here, with a variable. So what's going to happen, I'm going to erase this so I have a little bit more room to work. I'm going to split my middle term into the two numbers I just found. Well, I found a 1 and a 6, so 1x plus 6x. So I write the coefficient with the variable, and then I put it there. Really, I haven't changed anything. 7x is equivalent to 1x plus 6x. I've preserved equality, but I've just helped myself in this factoring process. Once I've split my middle term, everything else stays the same. So this 2x squared, I'm just going to bring that down. 2x squared, that was a positive 1x. And the 3, the constant, stays the same. So I just bring that down. So those two lines are actually equivalent. They just look a little bit different. My next step is to put brackets around the first two terms, and last two terms. So put brackets around the first two terms and the last two terms. Just a set of brackets. That's the fourth step. The fifth step is to remove, do that in blue. So remove a GCF from each set of brackets and then write what's left. So I'll look at the first step here, or the first set of brackets, and say, well, between 2x squared and x, what's the greatest common factor? Well, the greatest common factor is x. Now, if I'm going to write that and say what's left, I'm just really doing exactly what we did in the previous lesson by factoring with the greatest common factor. So I write my greatest common factor of x in the front, and then I write what's left after I've divided an x out from either or from each term. So 2x squared divided by x is 2x, and x, or 1x divided by x, is just a plus 1. Remember, those aren't going to cancel out. You have to include a 1 there. Then I'm going to do the exact same thing in the next set of brackets. So between 6x and 3, what's the greatest common factor? Well, the greatest common factor is 3. The 3 goes to the front, so that's a positive 3. And I write what's left after each term has been divided by your greatest common factor. So 6x squared divided by 3x is 2x, and 3 divided by 3 is 1. Now I have something really nice happening at this point, because if you notice what's here, okay, what's left in the brackets should be identical. And if it's identical, I know that I'm on the right track for my factoring process. If it's not identical, I either pick the wrong numbers back up here, or I divided out the GCF wrong. Something happened where I would have messed up. Okay, so what's left is identical. I'm good. Done that step. So the next one says remove the identical binomial as the GCF, and what's left over becomes the other binomial. So essentially what I'm doing here is like I would have done in this question, right, where I remove out a binomial of x minus 3 in this case. So what I would do here is I'm removing these out as the GCF. So that becomes 2x plus 1. Okay. What's left over becomes the other binomial. So x plus 3 those come together to give me the other set of binomials. Okay. And so there's my answer. I've factored that out. Apparently, these two binomials can be multiplied together and result in this trinomial. Now, I can always verify this, and that's, I guess, my 7th optional step here, which is to verify. Okay, verify by multiplying those binomials out. So let's just go and see whether or not this actually works to give me my answer. So 2x times x is 2x squared. 2x times 3 is plus 6x. 1 times x is a plus 1x. And 1 times 3 is a plus 3. So if I simplify here by combining these like terms, plus 7x plus 3, this is identical to this. So I know my answer here is correct. Okay. So I'm going to go follow those steps and do a few more just kind of basic examples. And then I'll give you some time, get you to pause the video and try a few on your own. So I'm actually going to get you to do B on your own. So I'm going to look at C here right now. X squared minus 25. Now, this example looks a little bit different than the previous example because it only has 2 terms. The thing is, I could actually make this a trinomial because this is equivalent to x squared. How many x's are there? Well, there's nothing in the middle here. So 0 x's minus 25. So now I have a trinomial, and I can apply these same steps to factor. So my first step, as we have stated above here, is to make sure we are from the highest degree to the lowest degree, and then remove a greatest common factor if there is one. So highest degree to lowest degree, I'm good on that. That's the next. Highest degree to lowest degree, I'm good. And there's no greatest common factor between those 3 terms. So I can continue to the next step. So then what I'm doing is I'm looking for 2 numbers that multiply to a times c and add to b. So a times c, add to b. So a is 1 times negative 25. So I'm looking for a number that multiplies to 1 times negative 25. So numbers that multiply to negative 25 and add to b, well, b is 0. So I'm looking for numbers that add to 0. So the numbers that multiply to negative 25. So remember, if you're 2 numbers to multiply to a negative number, one of those would need to be negative. So I could say, you know, like 1 times negative 25, negative 1 times 25, and 5 times negative 5. Those are the only factors that would multiply to negative 25. Then I have to see, do any of those add to 0? Well, if I add these together, I'm going to get, a negative 24. Negative 1 plus 25 is going to give me a positive 24, so it's neither of those. And 5 plus a negative 5 gives me 0. So I'm good. So that means these 2 numbers is what I would split my middle term into. So I would split that into a 5x and a negative 5x. Right, so I split the middle term, include the variable of these 2 numbers. And that's my second step there. Okay, find 2 numbers, split the middle term, and then it says everything else stays the same. So I will bring down this x squared. I can put a 1 there if I want, doesn't matter. And I bring down the constant of negative 25. The 4th step is to put brackets around the first 2 terms and the last 2 terms. So brackets around the first 2 terms, last 2 terms. And my 5th step is to remove a GCF from each set of bracket and write what's left. So I would divide this by a x and write what's left after I've taken out a GCF. So x squared and x, I'd have an x. Between 5x and x, I'd have a plus 5. Now I do the same thing to the second set of brackets. Second set of brackets can sometimes be trickier, determining whether or not you should remove a negative. My general rule of thumb is if I have a negative touching this bracket, I'll take out a negative. Or in this case, if both of these terms are negative, I'm going to take out a negative number. So between negative 5x and negative 25, the greatest common factor would be a negative 5. So that'll come to the front. And then I write what's left. So negative 5x divided by negative 5 is going to give me x. And negative 25 divided by negative 5 would give me a positive 5. If I didn't take out the negative, these two would not have been identical like they are now. So I know that I'm on the right track because what's left in the brackets here is identical. And so they get removed out as one set of binomials. And what's in front is what would be as the other set in the binomial. And again, I could always multiply that out to verify that these are actually equivalent. Okay. So I would like you to take a second for yourself and try B. If you have those steps, hopefully you have those steps kind of with you or written out or something, take a look at B. See if you can factor that by yourself. So pause the video and try and solve. All right, so hopefully you paused. Maybe you got stuck. Maybe you just kind of need a hint. So if I ever kind of say where you got stuck, pause the video and try and continue solving from there on your own. All right, so if I'm following the steps here, first thing I need to do, arrange from the highest degree and then remove a GCF if there is one. So here, this is actually not in order from highest degree to the lowest. So you should arrange it like this before you can continue to solve. There's no greatest common factor, so I can now move on to the next step. And the next step is looking for two numbers that multiply to a times c and add to b. So a times c and add to b. A is 1 times 20. So we're looking for numbers that multiply to 20, but add to 9. If you know those numbers off the top of your head, don't worry about writing out this whole chart. If you can't, you got to write out the factors of 20. So factors of positive 20 would be 1 times 20. Technically, negative 1 times negative 20 would also multiply to 20, but I'm not going to include that because there's no negative in this question. 2 times 10 and 4 times 5. And so if I'm adding these together, right, 1 plus 20 is 21. Well, I'm looking for two numbers that multiply to 20 and add to 9, so that's not part of it. 2 plus 10 is going to give me 12. Looking for numbers to multiply to 9, so that's not it. 4 and 5 gives me 9, so that's good. I'm looking to break my middle term with the variable into those two numbers. So I would split this up to become positive 4x plus 5 plus 5x. Again, I can do that because I didn't change anything. I just changed the way that it looked. It's still an equivalent expression. Everything else stays the same. My next step is to put brackets around the first two terms and last two terms, and then remove a GCF. So from the first set of brackets, I would remove an x, comes to the front, and then I write what's left. So x squared divided by x is x. 4x divided by x is 4. From the second set of brackets, I could remove a 5 as the GCF. So that comes to the front. And each term gets divided by the 5. So 5x divided by 5 is x, and 20 divided by 5 is 4. And hopefully if you tried this on your own, you can recognize that you're factoring correctly because these two terms are equivalent. So that becomes x plus 4 as one term. So that gets removed out as the GCF. And then what's left in front becomes the other set of binomials, x plus 5. So that whole thing is my factored form. Okay. All right. There's a few questions that I want to take a look at here. Let's try this one first. If you want to pause the video and try this on your own, go ahead. There's just the next two examples I want to look at are a little bit different than some of the other ones. So I'll take a look at and solve those. So again, I'm following that algorithm over and over and over again, looking for following those steps. Oops, too far. So 40x squared minus 40x plus 10. First thing I got to do, make sure it's arranged from highest degree to lowest degree so I can figure out the a, b, and c value. The second thing I should do is remove a GCF. Now again, that's not a essential step. It's just going to make my life easier. And in this question, there is actually a GCF. The GCF is 10. So I could take out a 10, and then I write what's left after everything has been divided by 10. So 40x squared divided by 10 is 4x squared. Negative 40x divided by 10 is negative 4x. And 10 divided by 10 is 1. And if you notice, I put a square set of brackets here just because I'm like saying that 10 is on the outside. I'm going to eventually add brackets in here anyways, so I kind of want to differentiate between my brackets. Okay, now I've partially factored at this point, right? I removed out a GCF as 10, but I haven't, oops, drop my mic. I haven't factored out this trinomial. And so now I'm going to essentially ignore this 10 and just kind of keep putting it out in front here. I can't totally be like, it doesn't exist anymore because I need it to preserve equality, but I'm just going to ignore it and put it on the outside. And now I'm going to factor this trinomial right here as we were doing the steps before. So I'm looking for two numbers that multiply to a times c and add to b. So two numbers that multiply to 4 times 1 is multiply to 4, right? And add to negative 4. So the numbers that multiply to positive 4 but would give me a negative number would be like negative 1 times negative 5 and negative 2 times negative 2. So when these add together, negative 1 plus negative 5, I get negative 6. So it's not these numbers. But negative 2 times negative 2 is going to give me a negative 4. So I'm going to split the middle term into those two numbers. Okay. Now my steps from here are the same. I put brackets around the first two terms, last two terms, and I need to remove a GCF out of each set of brackets. So I'm going to divide this term by 2x. That comes to the front. So 2x, and then I write what's left. So 4x squared divided by 2x is 2x. And negative 2x divided by 2x is a negative 1. From this set of brackets, it doesn't look like there's a greatest common factor. And the thing to know is we can always have 1 as a greatest common factor. So I divide out a 1 here. So this would be a 1. And then when I divide each term by 2x, I'd be left with a 2x plus 1 here. Now, I kind of did this on purpose here. These aren't the same. So I can't remove them. I know that I've done something wrong factoring. So I got to go back and examine my work to say, well, I messed up somewhere. Where did I mess up? So let's go take a look. So we said, let's start at the beginning. A, B, C. So two numbers that multiply to 4 and add to negative 4. That's good. So these two numbers satisfy the condition, negative 2 and negative 2. And that would be exactly where I messed up, is right there. I put a positive 2 in. So I'd have to split. This part is all okay. But now I have to go, this is a negative 2x plus 1. So to remove what I want to do, because this negative touches this bracket, I'd remove out a negative 1. So a negative 1. And now each term can be divided by that negative. So that negative 2x divided by negative 1 is 2x. And 1 divided by negative 1 is a negative 1. Now what's left in brackets is both 2x minus 1. So that would be one set of factors. What's left in front is the other. Actually ends up being the same binomial. Now this 10, can't get rid of it, want to write it in the front. Whether you put square brackets on there or not, it wouldn't really matter. So that could be a final answer. The other thing to know is, well, these are actually the same. So I could combine them to say 2x minus 1, well, there's 2 of them, and that's all being times by 10. So those are the same option there. I also want to point out here, had I not taken out like a negative number, or just had I not taken out a 1 altogether, this would just be like 2x minus 1 times 2x, and if I'm times 10, and if I multiply this all out, times that by 2x, sorry, 40x squared minus 20. This is not equivalent to this, or sorry, to this. So I need to make sure that if there is like no perceived greatest common factor, I'm still taking out a 1, or in that case, I guess it ends up being negative. Okay, one more example before I'm done this video, and then I will kind of give you some instructions from here. So let's take a look. So 4x squared plus 2x minus 5. Process is still going to be the same. Make sure you have increasing or highest to lowest exponent. So this should actually be 4x squared minus 5x plus 2 if I want to answer this question. So then I can say no GCF there, so I'll just continue on my way. I'm looking for two numbers that multiply to a times c and add to b. So two numbers that multiply to 4 times 2. So numbers that multiply to 8 but add to negative 5. So two numbers that multiply to 8 but add to negative 5. So let's look at all the factors of 8. So that would be like 1 times 8. Because this is negative, I'd want to also include negative 1 times negative 8. 2 times 4, and negative 2 times negative 4. So those are all the factors of positive 8. Now if I add these up, well, 1 plus 8 is 9. Negative 1 plus negative 8 is a negative 9. So none of these are getting to negative 5. 2 plus 4 is 6. Well, that's close, but it's not negative 5. And then even if I go negative 2 plus negative 4, that's going to give me a negative 6. So I can't find any factors. I can't find numbers that satisfy these conditions here. Unless I missed some, which I don't think I did because it's only numbers that multiply to 8. There's nothing that satisfies those conditions. And so if you run into that kind of question, that's what we would call unfactorable. And realistically, that is factorable. But in grade 10, you don't learn the strategy to be able to factor something that doesn't fit these parameters. So you can have questions that end up with, I just can't figure it out right now. It's unfactorable. Okay? Just to know, there's not going to be a plethora of those questions. What the outcome is can you factor, not can you identify an unfactorable question. So just kind of keep that in mind. Okay. So I only went through a handful of questions actually on this page. So what I would suggest, and I kind of messed this up, this should be an x here, 4x squared, so what I suggest is you take a look at this page on the scan note pack and just pick 1 or 2 questions, cover up the answer, and then try and solve it for yourself. Okay? There's obviously the homework there as well, but the homework worked answers might be a little bit harder to take a look at. So the answers for all of those are there. Expect a quiz to come out right away. And if you have any questions, please, please, please feel free to let me know. Okay? Thank you.